Hi, welcome to my video on part 2 of Radiant Measure of more than one rotation. This is the second video on radiance. The radiant measure of more than one revolution. A radiant is defined as the S over the R, and that's the S is for arc length, and the R is for radius of a circle. So let's find the radiant measure of each. The arc length of a circle is 16 meters. The radius is 2 meters. So the radiant is S divided by R. And S is 16 meters. The radius is 2 meters. They cancel out to give me 8. And there's 8 radians. So, in relation to this circle, the center is 0, 0. So, starting here, and in terms of a radiant, then we have a 0, we have 1.57, we have 3.14, 4.71, and all the way around is 6.28 in terms of one revolution, 6.28 radians. So we have 8 radians. So 8 radians. So what I'm going to do is use a red pen to do the rotation on the outside. So if I start here and rotate, I'm going to rotate like this. So watch. So when I rotate this far, which is right here, I would have gone, there's 8 radians, but I've only gone 6.28 radians so far. So what's left is 1.72 to go. So I have to go 1.72. So if I keep traveling around on the circle, there's 1.57 as far as here. So if I take off 1.57 off 1.72, I'll get 0.15. So that's a little bit more right here. A little bit more. So what happens, so if I'm going to use a different pin now. So if I start to rotate on the circumference of a circle, so here I am going around and around. So we travel. So that's this red one right as far as here. Then I go on up to here. And that's this part here, 1.57. And I end up right here. So the red is the rotation. So this rotation right here, ending up right here, is the radiant measure equivalent to the rotation on the circle. Okay, and if you had to draw a terminal arm going out through that rotation in terms of the radiant, there would be the terminal arm and there would be the angle that would be rotated, as if you went around the circle and around and came to here. So if you rotated this far as an angular rotation, then you would have the same rotation. B, the radiant, is defined as the S over the R, and S is the arc length, is the negative 15 over 2 inches, and make that inches now. The radius is 3 inches. So what I'm going to do is 15 divided by 2 is a negative 7.5. Make that a decimal, divided by 3, and that's inches. So the inches cancel out, and I get 3 into 75, or 7.5, is 2.5 pi, and that's in terms of a radiant. So in terms of, notice I have a negative rotation this time. So in terms of a negative rotation, this is 0. So this is a negative 1.57. This is a negative 3.14. This is a negative 4.71, because remember, positive rotation is going counterclockwise, negative rotation is going clockwise. So this is a negative 6.28. Or in terms of pi, this is 0. This is pi over 2 negative. This is a negative pi. And this is negative 3 pi over 2. And this is negative 2 pi. If you want to do it in terms of pi as a decimal or as pi. So let's rotate a negative 2.5 pi. So rotate, start here, and this is, I do it in red to show you as if I was rotating around on the circle. So that's a negative 2 pi. So I have a negative 2.5 pi. I'm going to take off 2 pi, so that's a negative 0.5 pi that's left, and that's a half pi. So pi is right to here, so a negative a half is right to here. So if I rotate it on the circle like this, watch, here I go, all the way around, right to here, so that's negative 2 pi, and a half pi is right to there. So that's the rotation in terms of the radian measure. Okay. And practice means pause your video and see if you can work these answers out. And here I go. We're going to find the radian measure for each. The arc length is 37.8 feet and the radius is 4. So the radian is defined as S over R, and that's the arc length is 37.68 feet divided by 4 feet. Feet cancels out, and take your calculator. 37.68 divided by 4 gives you 9.42 radians. And let's plot them in terms of, so we're going around the circle. So we, again, this is 1.57, 3.14, 4.71, 6.28, starting off at 0. So I'm going to do the rotation, and we start here. I'm doing the red. So if I go this far, right around the circle, and stop right here, then I got a 9.42, and I'm going to take off 6 or subtract 6.28, and that gives me 3.14. So I keep going, and I go 1.57, 3.14, and it stops right there. So in terms of a radian, it's 1 revolution and some more. So I'll go all the way around the circle like this, and I keep going, 6.28 and 3.14. So I end up right there, 9.42. And number 2, we have 9.6 radians, negative 9.6 pi centimeters, and the radius of the circle is 1.6 centimeters. So the arc length, the radian is defined as the S over the R, which is the arc length, which is a negative 9.6 pi centimeters divided by 1.6 centimeters. Centimeters cancel, and a negative 9.6 pi divided by 1.6 is a negative 6 pi radians. And we have a negative, so we have a 0. So this is a negative. This is in terms of pi, so I can put pi here, negative pi over 2. This is a negative pi. This is a negative 3 pi over 2, and this is negative 2 pi. Because we're rotating this way, this is a 90. 180, or it's a 90, 180, 270, and pi over 2 is 90. 3 pi over 2 is negative 270. Negative pi is negative 180, negative 90, negative 2 pi. So negative 6 pi, let's rotate. So we start here, and we make one revolution right around, going this way. So that's 2 pi. We go again. That's another 2 pi. It's negative 4 pi. And we go once more. We come right back to right where we started, right there. So a negative 6 pi radians is right there. We do the rotations. But so a negative 6 pi radians is really negative 6 pi radians is the same as 0 radians, the same as if you didn't rotate at all. So that's a radian when there's more than one revolution. And hope you enjoyed my video. If you did, click on the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye.